So we have Mr. Tahir, from Bank of New York Mellon, who is talking about crypto and the technology of cryptos, and he's trying to present to us about what really are these technologies and how these technologies are disrupting, and specifically what are the opportunities it presents to us in the testing and quality engineering space. I have the great pleasure in inviting Mr. Tahir. Tahir is a senior vice president, at Bank of New York Mellon. He's an avid crypto specialist. He has a lot of certifications to his credit on the crypto. When I was reading his LinkedIn, it was truly, in the spirit of crypto. All of them were like specific credentials, which is very unusual in the crypto space. So may I invite, Tahir, to come in and excite us with the topic of crypto and the opportunities it presents to us in for the testing community. You know, Tahir, over to you.
For having me here today and, of course, taking our time to listen to me. Um, in addition to the intro that Pradeep provided, right? So I am a nerd or a geek by heart, just try to understand and learn how things work, why they work, etc., etc. Got into cryptos, blockchain some time back, some years back rather. And yeah, so today, as Pradeep mentioned about the investments, I'm not here to make you rich monetarily. If that's the expectation, you should log off or probably take a break. But if you are looking to enrich your knowledge or grow in the knowledge space on cryptos and blockchain, then sure, this is the session. And yeah, let's jump right into it because I have a 30-minute slot. And yep, okay. So before we get into cryptos and blockchain, right? Before you get to a specific place, you always need to understand where we are coming from, right? So first, let's understand the currency generation principles challenges, right? So first and foremost, there is governance. There is a regulatory body. There are financial institutions like banks or credit card institutions. We have the Feds. We have RBI, so on and so forth. The currency generation happens through them, whether you're printing notes or whether a particular credit card is being issued to you, right? Those things are being done through that governing body, through a particular gatekeeper. For that, the in terms of the ownership management, you would need to give some sort of a government ID, whether it's the SSN, your Aadhaar, PAN, and whatever other identifications or forms of identification that you would have. There has to be that linkage, right, from a regulatory perspective. So that's how that ownership is defined, that hey, this card belongs to, say, Tahir, or this particular funding came into the bank from so and so route. Next is transaction management. Once a particular funding has been created, whether it's cash or whether it's a credit card, or even when you look at things like PhonePe, Google Pay, and other things, right? Those UPI platforms. The transaction management is such that there is again a particular entity, an institution, whether it's Visa, MasterCard, whether it's your particular bank, whether it's GPay, whether it's some entity that's looking at who the sender is and who the receiver is, right? Who are the parties to that transaction and whether they are authorized to be doing that and all those good things, right? So the transaction management is validated, authenticated, and all that is taken care of. Plus, of course, it's everything is logged, everything is being reported. We can log into our bank accounts, credit card accounts to check where we stand, so on and so forth. The support part, there is a support, a help desk, there is a customer service helpline where you can just call in case there is some fraudulent transaction, whether you want to dispute a transaction, etc., etc. Right? Those things are there. What we get at the end is tried and tested methods of centralization, censorship, and gatekeepers. Okay, these are the key things. There is centralization, there is some entity which is monitoring this, right? Whether it's a government, whether it's the financial industry, etc., etc. They can censor things if they want. I'm limited at time, so I won't delve into this too much, but okay. So then let's go into the inception of cryptocurrency, right? Why did this come about? Why did this happen? So this was around 2007, 2008 time frame where we had the subprime mortgage crisis, where the economy pretty much collapsed. Lehman Brothers and other huge financial institutions pretty much were at the brink of bankruptcy. And because of that subprime, if you're not familiar with subprime mortgage crisis, you should definitely Google it out, read about it. There are books on that, there are movies on that. It's a beautiful financial meltdown, right? Just to understand what transpired. Anyway, what happened at the end of it was that those financial institutions were looked upon as too big to fail. And so the government bailed them out. So taxpayers' money was fed into or funneled into those banks. And then you probably heard some horror stories about how there were some huge bonuses paid out and all that, right? So uh, anyway, normalcy was restored, but what transpired around that time frame was that financial institutions are evil. There was walk out of Wall Street and different things that happened, right? There was a huge lashback. There was just pain that was felt. Now, in terms of that, it's not about the financial industry being evil, right? It's not about any industry for that matter being evil. Okay. So it's just like QA or testing, quality, root cause analysis. You need to understand where the pain point is. You cannot just make it a generic thing. So in terms of financial institutions being evil, no, absolutely not. The institutions, the companies, the legal entities, right? They just companies. They've been created on paper by us. So who has created them? Who drives them? Who does these things behind the curtains, right? It's humans. It's us. So humans are greedy, humans are evil, humans are untrustworthy. That's the basic problem. Okay. So with that, so always remember that industries, they are just shell corporations, right? It's finally us humans who are not trustworthy, unfortunately. So with that, what happened was we had this person called Satoshi Nakamoto, pseudonymous. I call this person pseudonymous because we don't know whether Satoshi Nakamoto, we don't know the person's gender, we don't know whether it's one person or multiple people, etc., etc. Um, anyway, the point is that this person published a paper, and I have the URLs at the bottom, the Bitcoin PDF that came out around 2008. The paper was published, and then in 2009, Bitcoin was the platform was made available. So what this person came up was the general principle of creating trust in a trustless environment. So we have agreed that humans are probably not trustworthy, and we are taking away. Okay, so let me just break this up step by step, right? Let me not get ahead of myself. Okay, so the key things to note are it's a peer-to-peer version of electronic cash. It allows online payments to be sent directly from one party to another and without going through a financial institution. So let's break this up a bit, right? Peer-to-peer. A peer-to-peer network is decentralization, complete decentralization. So far, all of us have always thought about centralization, right? So there is always a central entity. There is a particular bank, a particular financial institution, or even if you think beyond that, say you have Amazon, Google, and all, there are servers around. Infrastructure as a service, platform as a service, so on and so forth. There is always the centralized entity that you pay to get services from. And if that entity goes down, well, everything goes down. So peer-to-peer, if you're familiar with torrents, BitTorrent, uTorrent are the clients, but if you're familiar with torrent, a peer-to-peer network is there is no centralized authority or centralized entity. Each of us become a node in that network, right? So as long as we have the necessary software that's running, the clients that are running on our own machine, my laptop, I can become a node in this Bitcoin network. I can become a node in the Ethereum network or whatever P2P, peer-to-peer network there is. That's the basic thing. The beautiful thing about that is that as long as those clients are running on these machines, the network will just continue living. There is no censorship coming in. It'll just survive. It is resilient to censorship. The next is electronic cash. Electronic cash is all about, now this is where it becomes a bit tricky. So here there is no physical coins. There are no physical coins at all. It's all intangible, right? Even if you think about NFTs, non-fungible tokens, or just tokens, ICOs, coins, etc. This is all virtual. This is not augmented reality like the game Pokemon Go, where you had the virtual reality and the, of course, the real reality. That's augmentation, but out here it's purely virtual. There is no physical part to it. Okay, even with things like GPay, PhonePay, and others, you are still transferring money from your bank, which is physical, to someone else's account, right? But out here, it's all virtual. There is no physical or tangibility to it. Of course, this says it's all online, so internet is a big deal. It has to be online. There is no offline available. Sending directly from one party to another. So just A to B, or of course, A can be just one person or a group of people, right? There are multi-party authentications and all. But anyway, not complicating this, that data, the money can be sent from one person or a group of people to others. And the biggest thing is without going through a financial institution. So out here, what need to think about is if you're looking at, say, these things that we had from the prior slide, I've got a couple of slides prior: governance, currency generation, ownership management, transaction management, right? All of this is baked into the platform. It's baked into the Bitcoin blockchain, it's baked into the Ethereum blockchain, whatever blockchain you're talking about, right? All of this is there. All of this is being driven by the platform, by the software. There is no central entity doing anything because the network that does all of this, it's a peer-to-peer network. I do this, you do this, pretty much everybody does this, right? The only thing lacking is, yeah, there is no support. So if you do a wrong transaction, your money is gone, at least for the time being. There is no rolling it back. Blockchain is immutable as it is. So, okay. So with that, quickly moving on to, so how does this happen, right? Now, I've just told you what the Bitcoin paper was all about. I'll just focus on how this comes into being, some of the implementations, or rather the implementation part of it. So this is called this is a Bitcoin wallet. I'm sure you're all familiar with the term wallet. Even in India, the market is blown. So you've seen wallets coming up left, right, center. Anyway, the wallet is something that holds your address. Now, this is based on cryptography, that is asymmetric cryptography. You have a public and private key algorithms, or public and private key RSA, if you're familiar, if you've heard about it. So every address is generated from a public key, and the public key is in turn generated from a private key. The private key is the root. The private key is just an alphanumeric string, nothing more to that. It's a unique string, and that's about it. The private key is key, and the term private, if you lose that or if you give it to someone else, yeah, your money is gone. So this is just, I wanted to focus that this wallet does not, by the way, the wallet has an address and the currency is tied to this address, but the wallet doesn't hold the actual money. The wallet only holds the addresses and the keys for the signing of the transactions. So how does the ownership and transaction management happen? Well, let's say Amy wants to transfer some money to Jerry, right? So Amy has a private key. There is something called digital signature. So the way digital signature works, and again, if you're familiar with, if you file your tax returns in recent past, then we are now able to digitally sign our tax filings, right? So that's pretty much it. So you have something called a private key in this case. The private key is used to hashify or hash the transaction such that a digital signature is generated. And then if a person has the message, that is the transaction, the digital signature, and the public key, then someone on the network could very well ensure that it is indeed Amy's private key that signed the transaction. So that's how this works. The private key always stays with Amy. Her public key is available on the blockchain, and that's how Jerry would confirm that. Okay. So this is how the public private key thing works. And of course, it has an account. Just going through the blockchain flow quickly, how this works is now, because this entire thing is spread about, right? There is no centralized authority that's doing this. How are the transactions managed? So every 10 minutes or so, the transactions are broadcasted to all the miners. I'm sure you've heard about Bitcoin mining. It's the way to earn money, earn Bitcoins, or even earn Ether. That's definitely there, but mining is akin to an accountant, right, who is making the entries on the blockchain. So if the blockchain is your ledger, the miner is the accountant who's actually making the entries in that particular ledger. The mining part is also consensus. It's creating trust in a trustless environment. And I'll talk about that. I know I'm running out of time, but I'll surely walk you through that too. So just for the time being, understand that miners are the accountants who make an entry into the blockchain, and they do it block by block. Blockchain, it's a chain of blocks. So the transactions are clubbed into a block. And then what the miners do is they solve a puzzle. Okay. Now, these puzzles are not the puzzles you see on WhatsApp groups and all that, right? Not the funny kind ones, but these are intensive. They're computationally intensive puzzles that require a lot of processing power. And it's deterministic, it's just brute force. You have to do it. So once the puzzle is solved, it's called proof of work, meaning if I'm making an entry into the ledger, I make it only after proving that I've done something which the system wanted me to do. Here's the proof. Now I'll pass that entry on to the blockchain for others to see. They will verify that, and that block will get added to the chain. And well, by the next 10 minutes, the next set of transactions will come into play. So let's focus now into the block puzzle, proof of work, and other good things. Proof of work computation, there's things called CPU, GPU, and ASIC. ASIC stands for Application Specific Integrated Circuit. Once upon a time, by the way, I come with around 21 plus years in the industry now, right? So when I started off, I had this Intel Pentium Pro processor, and that was the latest and the greatest at that time, which had the CPU. And if I tried to use that machine to do Bitcoin mining, it would fry my machine, right? It would total it. That's how intensive this proof of work task is. That's how difficult that puzzle is. So for proof of work, people buy specific hardware that's called graphic processing units. GPUs were made famous by the gaming community, but then of course the blockchain community took over too, the miners took over, and there are thousands of cores. So it does this processing, it can solve the puzzle fairly quickly. And there are specialized integrated circuits created too, right? So just wanted to let you know that the hardware, the network bandwidth, and the electricity needed is fairly intensive for these tasks. The public ledger by itself, this is an outdated slide, yeah. So what we see here is 40 gig. As of today, I think it stands around 250 to 300 gig size. It's growing by 50 to 100 gigabytes every year. And but what you see out here is that if I'm a node running as part of the blockchain or Bitcoin platform, then I have the ledger on my machine. Okay, it's as simple as that. I have the entire ledger on my machine. That's what I said. We all manage the entire set of accounts. Now, eliminating dishonesty is the key, because if I have a file, I could easily fat finger it, right? So let's explore that. But before we go there, now let's focus on the blockchain. What's the blockchain? For my folks from IT, right, this is nothing but a linked list. Okay, so the top one, it shows a standard linked list, right? First, next, 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 and the bottom one shows a reversed linked list. So linked list is a data structure in computer terminology, computer science. It's a list of nodes. You can go from left to right, or you can go from right to left, or you can have a bidirectional linked list, right? Blockchain follows the reverse linked list, where say if this is the last block points to the block before it, so on and so forth. It goes all the way to the root. And okay, so with this, just the basic principle, let's also look at hashing. Sorry, I have to rush through this. Okay. So in terms of hashing, and I'll just come to the next slide where I'll tie the linked list and the hashing together. So just bear with me. Hashing is something that, so if you've heard of things like SHA-256, secure hashing algorithm, and KeySack, there are lots of algorithms out there. But what a hash does is it takes an input of any arbitrary length and it gives a unique hash value of a fixed length. So if I give something like 10,000 character string to the hash input, I just expect the output to be 100 characters long, but it'll be unique. So it'll only be unique if the input is different. So let's say as a human being, right? The simplest example that I can always think of is, as a human being, if I have to hash myself, what is my hash? My hash is my fingerprint, right? Or biometric in some way. So just taking the fingerprint as an example. So to be able to identify a human being, let's say we go with the fingerprint, that's what hashing does. You give Tahir to the hashing function, it'll give the fingerprint and it'll say that's the hash of it. Okay. So this is where the Bitcoin sophistication comes in. How does, as I said earlier, all of us have the blockchain, the ledger with us on our machines, right? Well, not everyone has to have it, but that's another thing. The reason I shared my LinkedIn profile, by the way, previously was that this is a very short duration for me to cover this. So if there's anything, feel free to reach out. I'll be happy to answer and provide more clarity. But okay, coming back to this on terms of how does this work? So if these are blocks, every block's hash is taken, right? As I told you earlier, transactions are clubbed into a block, and then every block's is hashed. Its fingerprint is created. If this is my first block, this is my Genesis block, right? Then this guy's fingerprint is taken by the next block's fingerprint, or is taken by the next block, and the fingerprint is then generated for the second block. Similarly, when the third block comes into existence, it takes the second block's fingerprint, and then the third block generates its own fingerprint. So now let's start from here, right? That means the fifth block has the fingerprint of the fourth block, the fourth has the fingerprint of the third block, so on and so forth. So in a way, the last block, whether it's the fifth block, the 100th block, the 1000th block, the millionth block, it'll always have indirectly the fingerprint of the all the way to the first block, right? In fact, it has fingerprints of all these blocks, right, all the way to the root. So for instance, now if I wanted to fat finger the data here, if I change the data within this block, its fingerprint will change, okay? If the fingerprint changes here, then because the fourth block had the fingerprint of the third block, even this guy becomes invalid, fifth becomes invalid, all these succeeding blocks become invalid. That's why this is that proof of work, this is that immutability and good things that ensure that you're not able to fat finger the blockchain. Well, you can still do it, and I'll talk about that in terms of vulnerabilities, but it's not worth it. So, okay. Now, quickly, this is what a block looks like. You have the version of the block. So as I said earlier, right, you have the block of the prior, the hash of the prior block. There's a Merkle root. I have that slide out here later in the appendix, but a Merkle root is nothing but it's a reversed tree where you take, say, multiple transactions, n number of transactions, and finally collapse or hash them all into one single hash. Okay. Merkle root is used again in computer science, like multiple companies use it. But okay. And then there is a timestamp, bits and nonce, and finally the fingerprint of this block is taken, and that's the block hash that's created. So this is that fingerprint, right? Now out here you see something called a nonce. So let's quickly jump into that. The proof of work or the puzzle that I was referring to, this is the key thing, right? So what you see out here is, let's say, and again, since this is for software, right? I'm sure people know what hashing is and algos and all that. So let's say if I have a string called hello world, and I want to give it to this input, and it gives me a particular output. Now, if I always give it hello world, the output will always be the same because it's deterministic. What Bitcoin's blockchain wants is that the hash, the output hash that I get, should have some number of preceding zeros, not 4. It has like 8, 10, or there's a number and that difficulty changes. But the point is that the output should be such that it has some number of preceding zeros in it. Okay. But if I give it hello world each time, I will always get the same output. So what I do is think of the nonce as a counter. So for nonce equal to 0, nonce is less than something, nonce plus plus, and within the loop, I concatenate the string, that is the block's value or the block's string, along with this nonce, and I hash it, and I keep on doing that until I come up with something that meets the blockchain's criteria. Out here, as you see, finding a match for hello world with 4 preceding zeros took 40 to 51 tries. Okay. In the real world, when the transactions are mined, it takes around there are millions of tries that are done. Okay, and that's why this is computationally so intensive. That's why we have transactions being broadcasted every 10 minutes, a blog being created every 10 minutes. Yeah. As I said earlier, this is expensive and immutable. So if I wanted to say fat finger a particular block, right, and if I had lots of people coming with me to fat finger this block, even if I was able to tweak it, end of day, what is happening here, right, is that whatever I'm reversing, but the amount of effort that I'm putting into the mining, is it worth it? So is it worth it? Is the ROI, return on investment, is it worth it or not? That's what makes it better. Okay, this is the Bitcoin transaction, how it works. As I said earlier, public-private keys, hashing algorithms, nonsense. It's a beautiful, beautiful solution, the way Satoshi Nakamoto brought all of the existing things together, a lot of focus on cryptography, hashing, and other things. And that's how this comes into play. Now let's jump to Ethereum, the word computer. There's something called Web 3.0, and there's a question too. So Web 3.0 blockchain. I'll just quick. When we talked about Bitcoin, what Bitcoin gave to the world was decentralization, right? Bitcoin's blockchain, and that was coins. That okay, coin from one person to another. No need for financial intermediaries. There's this person called Vitalik Buterin who created Ethereum, and that person took that notion a step further and said that okay, I'll create another blockchain with all those underlying principles, but this particular blockchain is not just for currency transfer. This is a Turing complete blockchain, meaning it has its own programming language. You can write programs on it. Those are nothing but smart contracts. So you write programs and you publish those programs to that blockchain. And once those programs are published to the blockchain or deployed on the blockchain, then that becomes a smart contract and you start interacting with that. So let's say just the world computer, simplistically, it's data, something input goes in, it processes, and an output is created. So from an Ethereum standpoint, how this works is you have a transaction. It's a state machine. A transaction initiates something. A transaction is how you interact with the blockchain world. So that's where if you have a smart contract, then once you deploy it, you start working with it. One of the questions is around Web 3.0 blockchain and crypto. Web 1.0 was the standard web that we saw. Web 2.0 was more about interactive content and all that. Web 3.0 is the decentralized web. So this is just, we are looking at the blockchain. There is something called Swarm and IPFS, which is interplanetary file system. It's a peer-to-peer network where you can store files. So not only is your smart contract decentralized, your file storage system is also decentralized. There's something called Whistle, which is a, a chat protocol, right? I forget the term, sorry, but yeah, that's another. So these are different protocols that are coming out, and Web 3.0 is nothing but decentralized web. So rather than surfing based on a particular URL, now you would be surfing based on hashes, because in the decentralized world, everything is a hash. Even in my interplanetary file storage, where I'm storing the files through a peer-to-peer network, everything has a hash eventually. So rather than storing things on cloud through Amazon and others, my entire, when I talk about decentralized applications, right, these would be stored on peer-to-peer networks, and I would be accessing it through hashes. And that's what your Web 3.0 blockchain and crypto is all about. Okay. Sorry, just I'm running out of time. I'll just take 5 more minutes and then open it up for questions. And if we have more time, okay. Differences in testing opportunity. So out here, what we have seen is it's a distributed network. Okay, it's peer-to-peer. It's spread out. There is no centralization. Whatever things that we have looked at from a financial institution or the governing bodies or infrastructure platforms or whatever services that people provide or companies provide, you're moving away from that. Now it's all by the people, for the people, of the people, right? It's as simple as that. The next thing is it's not free. There is something called a fee that's need to be provided. In the Ethereum world, it's called gas. Whatever you call it, fees, gas, but finally there has to be some amount that needs to be paid. Now think about it. If I'm using the services of a bank or some institution, or if I'm hosting some files on a particular Google or Amazon or somewhere, I'm paying them something, right? So similarly, for me to be able to use the Ethereum world computer or the Bitcoin blockchain, I need to provide a particular fee because that's where everything is happening, right? But here the fee is happening per transaction. It's not like postpaid or anything, or it's not prepaid. It's pay as you go, meaning when you do the transaction, you pay fees for it. The next thing is it's immutable. So if I deploy a smart contract onto Ethereum and tomorrow I realize I made a mistake on that smart contract, I cannot change that existing smart contract. That smart contract will have a particular hash ID to it. Now, if I fix my smart contract and I deploy it, it'll have another hash. It'll be a different instance altogether. Okay. So that way, there are proxy patterns and other architecture patterns that you would use, but it's tricky. It's not straightforward. So immutability plays a big role out there. And then, of course, vulnerabilities. There have been instances that you would heard of people stealing from. There was something called a DAO attack, decentralized autonomous organization. People stealing money. Now, out here, just to be very clear, the blockchain is safe. Okay, but if private keys are leaked, then there's a problem. And the smart contracts are nothing but programs. They can be written in a programming language called Solidity. There is Viper. There are a bunch of programming languages. But finally, it's we who are writing those pieces of code, right? And we could leave some vulnerabilities open. Just like if you, when the computer was introduced, we saw that viruses and hackers came up with ways to hack into the systems and steal things out. Similarly, out here, the Bitcoin platform, the Ethereum World Computer, it's all just in its infancy stage. Right? It's a computer finally. So if hackers can think about how to hack into a physical computer, this is more like a virtual thing. Yes, people are trying to hack into it and do things. So vulnerabilities are there. There are a bunch of vulnerabilities, but things are getting fixed as we speak. Out here, what you need is, of course, the BDD and TDD mindset. Behavior driven development, test driven development. You need to really understand what it is that you're trying to accomplish. From a testing perspective, we have test networks like Ethereum has things called Coven, Rinkeby, and others. Bitcoin has something called a test net, where you deploy something. So you're not putting your contracts or your functionality all it's on the live or the prod chain. So just like we have prod, QA, and dev, there are also dev blockchains available, right? There's thing called Ganache, which is a local node. Even Bitcoin has that version, by the way. So you can have that on the developer box. You can have it on the test network itself, and the test network requires test currency because, as I said earlier, right, everything has a fee or charge. So nothing for free out here. The only drawback with the test networks is the way the mining is done. It's somewhat relatively relaxed on the test network, so you'll not be able to mimic everything. So until you go to prod, you'll never truly find out what's wrong, but that's a risk. Okay. In terms of from a testing perspective, we have languages and frameworks called there's a framework called Truffle, which allows using Mocha and Chai. So that's pretty much it follows the BDD TDD principle. If you're familiar with Cucumber and things like that, then it's pretty much on similar lines. You will need to have knowledge of Node.js, JavaScript, and also some amount of Mocha and Chai and whatever other frameworks that you are using. Okay. Now, this is a question that I've been asked, like, how do I get into this? Not just from a testing perspective, but even BAs and developer community and all, right? How do I start doing this? So whatever I just mentioned, like Mocha Chai, Truffle, Solidity and all, it's just syntax. It's just syntax. It's not a big deal. I mean, anybody can learn syntax, right? The biggest problem that we face here is a changed mindset. That is key. The entire, and it was correctly asked by, I think, Sarvana, right? So thank you for asking that question, right? Web 3.0 is how it's the terminology for it, right? That's Web 3.0, the entire decentralization, distribution, peer-to-peer. That's the way we need to go to. So far, we have been conditioned in terms of centralization, right? We cannot go beyond that. So that mindset change is the first and foremost thing that's needed. And once you understand that, the reason I gave the history for two is the key principle about creating trust in a trustless environment, that trying to just keep people honest, forcibly honest, right? Those are the things. So once you understand those base building blocks, the rest of it is just syntax. It's never a big deal. Okay, anybody can learn that. So get that, and then you can get into this brave new world. So I have short over time. I'll pause now. I have some links. I've published things like NFTs and no Bitcoin. Just have a look at my LinkedIn profile. And there's a Merkle route, but that's fine. I'll pause for questions. Thanks. Sorry, I had to rush through here. Stuff.
Yanika can go on. Yeah. Great. So certainly we are richer for sure, Tahir, in the sense we knew what actually makes money in the whole process. Okay. So we certainly like that part of it. But I think there are two interesting questions here that I had for you. One is a philosophical question in terms of how the whole operating model works. Because again, I completely agree with you that we are conditioned to believe centralization, conditioned to believe that power should be given to certain regulatory bodies. But there is also a positive effect of some of these regulatory bodies. Like just to give an example, like governments, when such a crisis occurs, like recently COVID happened,
Correct.
and the government in the US, for example, pumped in trillions of dollars to keep the businesses afloat. When such a situation happens, which as in the way COVID is mutating, I believe this is going to be a norm of the day. So we will have Omicron, we will have probably some other variant coming soon in 6 more months, right? The question is that to control the inflation, to control the economy, to keep it running, governments certainly do activities of solvency, some forms of solvency, right?
Okay.
Now, how does Bitcoin really handle that? That's one question. And if it cannot, then will it be will the decentralization really help? Right? That's one philosophical question that they have.
Sure.
The technical question for you is what if the number of nodes reduce drastically in the future when they feel mining is not profitable anymore? Right?
Sure.
That's another technical question. That's what I call as an OTH moment for me, because that's completely overhead transmission, So, but that's for you, So, over to
Okay.
you.
Sure. Thank you for that. Yeah. Okay. So on the philosophical part, yes, absolutely, right. Completely agree that. So here's my take. It's never my way or the highway, right? And that's what life has taught me, and that's what I believe in. It's always a hybrid model. So it's never going to be complete centralization. It's never going to be complete decentralization. There has to be some middle ground where people meet and the government meets the public, and finally that's taken forward. Because see, unfortunately, what happens is the forbidden fruit is always the sweetest, and yeah, that goes back to Adam and Eve, right? So if Bitcoin is say banned completely, right, or whatever cryptocurrencies are banned completely, that makes it a forbidden fruit, and people will now start looking at it from a black market perspective and all that. So that could lead to different problems altogether. In fact, initially it was all about darknet and cryptocurrencies, right? That's how it started off, and that had a bad name earlier. But the point now is that it has become quite mainstream, especially with smart contracts and different things, where you're looking at, say, supply chain and just global identifications and all that, right? So, of course, from an Indian government perspective too, there is talk about a digital currency that India government will provide, and similarly, there are some other countries who will go that route. The point is that there is this middle ground that's being taken. Now, the decentralization part of it, uh, whenever you take away the decentralization and the censorship control out of the blockchain, it's not truly a blockchain, because blockchain is all about public, by the people, for the people, of the people, we managing it, everything, right? As soon as there is a centralized body coming in, that sort of negates whatever Satoshi Nakamoto came up with. Okay, but of course, a hybrid model has to survive end of day. That's the answer to the philosophical answer to the first question that you had. The second one is inflation. Yeah, inflation and deflation. So inflation, yeah, the regulatory bodies, governments and all do control that. I completely agree, right? But the way Bitcoin has been created, it has 21 million coins, which will be happening for some more years, and after that the Bitcoin generation will stop. So that way it's more of a deflationary currency. Okay, there's no inflation out here that's happening. Similarly for Ethereum and whatever other coins that you see, they all follow more or less a similar philosophy, where the currency generation is controlled. So it's not like the currency will just keep on growing and growing and growing. And that way, as long as anything is limited in supply, right, its value will automatically go up. But then, of course, we don't want to get into the inflation side of it or the flip side of it. So the way the fees work or the mining reward is going down over the years, and the fees in between on especially on Ethereum were going quite up. But now we are talking about Ethereum 2.0 and layer 2 scaling and all those good things. In fact, there is a London fork which is called EIP 1559, which
True.
brings out a new fee model which simplifies things, which is now giving less to the miners in a way and ensuring that everybody is able to access or use the
Access.
blockchain.
Correct.
Okay, so that's how the inflation and deflation is. It's a self-balancing, it's a self-sufficient system. In fact, if you look at the white paper and the even the yellow paper on Ethereum, it's beautiful the way the system would pretty much take care of all the use cases. Okay, so then that brings us, in fact, that ties in beautifully into the technical question about if the miners give up, right? What happens? So excellent question. Now, in terms of ETH 2.0 and the 1559 EIP 1559 or the London fork, what happened recently is that there is ETH which is burnt. So there is a base fee and then there is a miner tip, right? A fee tip that you're giving to a person who's mining it. The base fee is burned away. Burning the fee in the blockchain world is just sending it to a 0x0 hexa address, which is sort of non-existence. Once you send money to that, it's gone forever. It's into void. Okay. So by doing so, the value of whatever Ethereum that is there, the supply is being reduced like on a continuous basis. So the value of Ether currency will always remain stable if you think about it that way. It's not about inflation,
Okay.
deflation, but the system will keep it stable. Now, miners giving this up, of course, yeah. If all the so think about torrent, right? If we were asked the question, or if you think about the torrent peer-to-peer network, or even IPFS and all that, right? If I am dependent on those networks, right? The peer-to-peer networks, as long as a single node is alive, it'll be alive. Okay.
True.
Many organizations have already set up a lot of infra for keeping these blockchains alive. Now, in terms of mining, yes, so miners get a reward. Currently, in Bitcoin, they get a reward, which is called the coin-based transaction, where they get a coin created for them. Moving
True.
forward in the future, they will only get the fees. They won't get that reward because by then the currency publishing would have been stopped, would be completed, be exhausted. So then they will
Got it.
only be continuing on fees. And that's the thing for the miners. Right?
Got
Think
it.
about it. So much hardware infra rigs have been created, so much mining infra has been created. It's not going to be throwaway. And the way Ethereum is catching up, the way Corda and Hyperledger and other blockchains are also coming up, once you have things working on these platforms, then automatically the transactions are happening. As of today, you know that there are these decentralized exchanges. A lot of trading happens. What are these
True.
dexes? They're nothing but smart contracts in a way, right? If you look at it under the covers, of course, it has a UI and all those good things, but under the covers, it's a smart contract. In fact, it's a super smart contract. So the
True.
point is that as long as that exists, there will be people who support it. Okay, so the lights
Perfect.
will always remain on. Yeah, lights will remain on.
No, perfect. And unless Mr. Musk comes up and plays a Thanos one night, in the sense, that's the only problem I have with the whole thing. He certainly would keep, as in one tweet of his could probably destroy, one currency
Yeah,
and
yeah,
then build up
correct,
another currency,
correct.
right? So
That's true.
that's
That's
so
true.
at the end of the
So,
day, I completely am with you. You know,
mhm,
I as in I think it's a very interesting perspective that you brought in. That all the testers need to really think about the cross linkage between Web 3.0 and the kind of a process that we go through, and the whole design of this particular solution. And having a familiarity with that particular solution and the depths of it and the way it really works is quite technical. And
mhm,
that's where I see a convergence between both the testing and the development world together. And then the
correct,
idea
correct.
is that you think from a possible failure point and design a system, is something that's a very exciting part for the entire community as well. So
Sure,
thanks a lot, Tahir, in the sense,
sure,
really
Pradeep.
wonderful. I think we should probably next time give you 2 hours, and probably create a mini tutorial on the whole thing,
Yeah, I wanted to
because
jump
we
into
would.
Ethereum a lot. Yeah, smart contracts and ERC20 and 721 and all those good things. Sorry, Pradeep, I'll just
No,
take
no,
1 minute. I'll just take 1 minute
yes,
before
yeah.
you push me out.
Okay.
So, in terms of
Yeah.
the miners and all not available, there was this very famous movie called Fight Club, Brad Pitt and
Hmm.
Edward Norton. In that,
True.
they destroy all the banks, all the financial institutions. I mean, for whoever has seen the
True.
movie, right? Now, of course, we
Yeah.
live in a global world, but when the movie was made, they ensure that they collapse the financial system completely.
Correct.
Okay. Well, that happened in that movie, but we have never seen it happen in real life, and I do hope that it doesn't happen, right? But the
True.
point is that this will always continue.
Hmm.
Humans are resilient that way. Even though we are evil and untrustworthy, we are resilient. So systems will have a life and they
Absolutely.
will
No,
go
no.
on
If
and
you
on
have
and
a,
on. Yeah.
yeah, the way I look at it, Tahir, is if you have evolved from a barter system, all the way to having a complex stock exchange,
Correct.
I'm sure we'll invent another level of complexity to keep
Right.
ourselves occupied and busy. And of course, there will be more convenient methods of operation as we go forward. But I think the fundamental principles will remain intact. In the sense that has not changed over the last,
Yes.
centuries that we have been. So
Absolutely
in
correct.
terms of assigning a value, in terms of ensuring a supply and ensuring a demand, if those principles are maintained in a correct way, I think we are good. In the sense, of course, there will be corruption. Of course, there will be leakages. Of course, there will be people who will steal. As in,
Yeah.
like the counter argument I always give when people tell me about crypto is that it is not that, like, if you have police that the crime won't happen. In the sense, you certainly will have crime in spite of a police force existing, right? So does it mean that you would say that let's remove the police force and let's have a day of purge? That's also not a good idea.
No,
So especially me living in the US, I have those worries. If
I know.
one day someone in the community decides to do a purge, it'll be a horrible night for me. So
And that's,
anyways,
knock yourself in. Yep.
thanks
Yep.
a lot, Tahir. I